we will do, because we are meeting after a long gap, and I'm very sorry about that, because there was kind of a problem at my home, so I couldn't take your classes regularly. And all those rituals that are needed to be performed after the departure of family members. So I went through that process, and so I couldn't engage your classes, but we will surely get along with what we were discussing. So I'm just scrolling through all those things that we discussed in our last classes. We talked about the electrophoresis procedure. What are the different ways of performing electrophoresis, in which we broadly focused upon two classes, as the moving boundary electrophoresis and zone electrophoresis. And within zone electrophoresis, these are the ones that we are going to discuss in greater detail. So we began discussing something about paper electrophoresis. If you remember, we began discussing something about paper electrophoresis procedure in the last lecture that was conducted, and today we will be talking more about another form of paper electrophoresis, and I hope that you still remember the basic mode of operation of paper electrophoresis procedure, which is horizontal mode. However, sometimes it has been observed that vertical mode of electrophoresis works better when we are talking about paper electrophoresis, because it's a faster way of performing electrophoresis, going along with the gravitational force. However, it certainly depends upon what type of molecules you are separating, or right. So essentially, it actually depends on different forms of molecules that we are just. Sorry for this. I got a bit distracted. So I let's get back to what we were talking. Yes, we were talking about paper electrophoresis procedure, and there are two modes of operation. One is horizontal, another is vertical. Depends upon essentially which type of molecules you are separating and what kind of resolution you are expecting when you are performing paper electrophoresis. We also went through all these four steps of paper electrophoresis method, and we talked about how or what is the role of apparatus. Like I gave you an example that there is a horizontal mode as well. So we talked about first the type of apparatus that is used during paper electrophoresis, both vertical as well as horizontal. Then no matter what type of an apparatus you are using, sample application is one of the very what you can say very essential step of electrophoretic procedure, because it depends upon how you are performing or how you are applying the sample. You can apply, in case of paper electrophoresis, you can apply sample in two different manners. One is either you can apply it as a spot, or you can apply it as a streak. So I explained it to you in the last class itself that imagine that this is your paper, and you want to apply several samples at the same point of time, then you can apply it as a spot. So, or if you want to apply it as a single sample, and then you want to, now it depends. Essentially, if you want to apply sorry, I dropped off. There is some internet issue, I believe. I will be sharing my screen again with you. You can move ahead from. Okay. So we talked about all these aspects, that sample application, electrophoretic run, that how it is carried out, what are the precautions that you're supposed to take during electrophoretic running. And finally, we talked about detection and quantitation. It depends upon what type of, if you are separating proteins, then you use a different detection method. If you are within proteins also, if you are separating, say, enzymes, then your detection procedure can vary. And also you can quantify the separated components. You can actually determine that what is the concentration or what is the amount of the separated molecule. So whether it is protein, whether it is nucleic acid, whether it is carbohydrate, it depends on that what type of detection method you are going to use. Essentially, we use electrophoresis for separation of proteins and nucleic acids, and hence carbohydrates are not pretty much concerned, because only charged carbohydrates can be used can be separated during electrophoresis. However, there is an interesting aspect here about the carbohydrate moiety attached to proteins. And when essentially the molecule is a protein, but it has certain carbohydrate units attached to it, it is referred to as a glycoprotein, and there is a completely different variant of paper electrophoresis procedure that is used for detection of glycoproteins, and that is what will be discussing today. So this is just a glimpse of the two different modes of performing paper electrophoresis, horizontal as well as vertical paper electrophoretic procedures. We already discussed about that in the last class. So now we essentially shift our focus onto cellulose acetate paper electrophoresis procedure, which is the variant of usual paper electrophoresis procedure, and the variation is needed because the cellulose acetate, which is a form you can consider a modified form of paper. Now, when we understand paper in paper electrophoresis or in chromatography in general, we essentially believe that the paper is maximally containing the component that is cellulose. However, when we look at paper as what you can say as a stabilizing medium for performing electrophoresis, is essentially cellulose is also contaminated with uh, a, a form of cellulose, a derivative you can say, is also called as a xylene or hemicellulose. So hemicellulose is going to be there uh, as a contaminating component of cellulose in paper. Apart from hemicellulose, there is one more component that adds up and is called as lignin. Lignins are quite complex as well as they contain certain aromatic components. Hemicellulose is called as xylene because it consists of different. It is also called as xylene because it consists of different forms of sugars, essentially xylulose and other derivatives we can consider of pentoses as well as hexoses. So it consists of different forms of sugars joined together. So it's still essentially a sugar polymer till we reach up to cellulose and hemicellulose. However, as soon as we go into the portion of lignin, you can consider that it's actually uh, an aromatic polymer consists of different forms of aromatic components, essentially phenolic units. And because of those, uh, all the problems that you essentially during realize that okay, I don't know from which point did you lose me? Getting dropped off pretty regularly today. I don't know what's the problem with the net. Can you hear me?
Yes, sir.
Okay. Good. Fine. But I was dropped off. So what point did I drop off? I don't really know. So let me share my screen again with you. Yes. Okay. Good. So okay. Let me again go to the point that we were talking. Can you still see my screen?
Yes, sir.
Okay. Okay. So are you able to see the cellulose acetate paper electrophoresis slide?
Yes, sir. Yes.
Okay. Good. Good. So fine. So now, are you able to see the slide, or it is gone?
It is visible, sir.
Still visible? Okay, good. From my side, it's there is a problem, I believe. Okay, fine. So, so when you're talking about cellulose acetate electrophoresis, the drawbacks which are associated with cellulose or paper electrophoresis in general are taken care of here. So what is done is basically you purify cellulose, you make it essentially pure, remove hemicellulose and lignin contamination from paper, and then you perform a chemical reaction by the way of which you can convert cellulose to cellulose acetate. Now, what exactly do you think is happening here? Basically, what you're doing is that you're converting the hydrophilic groups, that is the hydroxyl groups of cellulose, you are modifying those groups and converting or adding an acetate, what you can say, group over here. So when you will add an acetate group, what kind of an advantage you will draw from this? Can anybody think about an advantage of adding an acetate group to the hydroxyl groups? Yes? Anyone? Essentially, it will become less hydrophilic. Okay, because of addition of the acetate group, it will become less hydrophilic. And now, because it is less hydrophilic, whatever the absorption power that was associated with paper alone, in cellulose acetate, that absorption property is weakened. And the problems that you were facing when you were performing paper electrophoresis, essentially, if this is a paper, and if you spot your sample like this here, during paper electrophoresis, what was happening is that when, when migrating, the sample used to be getting converted into certain elongated spots as the sample was getting dragged, because some of the molecules still remain attached with the water that was forming a hydration shell around the molecule of your interest. And that was holding your molecule as well as the molecule's own ability to interact with these hydroxyl groups through the absorption power of paper, was holding your molecules back onto paper, and they were just dragged over the paper during normal paper electrophoresis procedure. As soon as you convert these hydroxyl groups into or you modify them to the acetate or acetyl units, then what is going to happen is that because of less hydrophilic environment, this absorption power of paper is weakened, and you will get essentially good spots rather than getting dragged spots. You will get essentially clearly resolved kind of spots. Okay, and that is what is an advantage of cellulose acetate paper. Two, because it is not going to be very hydrophilic and it will not be holding water to a great extent, the buffer will essentially move over the paper and will not percolate into the paper and will not be held up into the paper to a greater extent. That creates another kind of a problem that we will be discussing slightly later on when we talk about gels in greater detail. But just for your understanding, that problem is referred to as a process of called that is called as electroendoosmosis. Now, okay, I will explain it to you in case I forget explaining it to you about the procedure. I'm just giving you a name so that you remember the name, and later on you can remind me that I just forgot mentioning about the process. However, I will make it a point that I explain to you what is electroendosmosis, and that creates a great deal of problem during electrophoresis. And that happens essentially in cellulose base, that means normal paper electrophoresis. However, cellulose acetate paper electrophoresis procedure gets over that kind of a problem. So let us discuss what are type of advantages of a cellulose acetate electrophoresis procedure. And then I will give you a very hallmark kind of an application still associated with cellulose acetate paper electrophoresis procedure. And I don't know, those of you who have your near ones or your parents suffering from diabetes, perhaps you might have heard about this kind of a diagnostic test that is performed. But we'll come to that slightly later on. Let us first discuss what are the advantages of this procedure of cellulose acetate electrophoresis. As I have already told you, it's chemically quite pure. It's devoid of lignin, hemicelluloses, and essentially nitrogen, which is a part of, you can consider, lignin components. Okay, and that might create certain problems because of the associated reactions that might happen during the development of electrophoretogram after the electrophoretic procedure is over. Because as you all must be knowing, most of the proteins, if essentially you are interested separating proteins, most of the proteins are colorless. So if you want to separate, and after separation you want to visualize, then you will have to run some kind of what you can say, some kind of a detection method. And those detection methods are essentially based upon, for proteins, it's a ninhydrin reaction that you very commonly do. And I hope that you remember the ninhydrin reaction of proteins. It reacts with the amino group nitrogen. So this nitrogen of the paper itself is going to create problem during this development process. Two, many of the times you perform certain more specific and more what you can say precise kind of detection methods using fluorescent agents, which are going to fluorescently label your protein. So when you're going for fluorescence, the problem is associated with lignins, because lignins, as I told you, will be containing certain aromatic components. And we all know that aromatic groups are quite fluorescent. And so when you are performing normal paper electrophoresis, presence of lignin is going to create a great deal of problem for you. So using cellulose acetate over paper electrophoresis becomes quite advantageous in terms of getting better resolution as well as having an edge in the detection procedure as well. Second important thing about cellulose acetate paper electrophoresis is that the cellulose strips that you get while converting cellulose to cellulose acetate, these cellulose strips are essentially translucent. That doesn't mean that they are completely transparent, but they are quite translucent, and that makes it quite easy for photoelectric detection. Like we all know that papers are mostly not transparent, right? And hence, if you just want to detect it by using, say, UV detection method, don't want to modify the proteins which are separated, just UV detection, then the problem will be that you will have to have the detector as well as the light source on the same sides of the paper. And then the detection procedure relies essentially only on scattering and not on absorption. So if it is not relying on absorption, then it becomes quite a tedious way of detecting that where is the protein. So imagine that this paper is essentially translucent, something like what you get when you dip, dip the paper in oil. Okay, just imagine that you have dipped a normal cellulose paper in oil, then it will become absolute, not completely transparent, but it will become translucent. You can use it for the photoelectric detection and for scanning for the separated protein. So that can work good for you. If you are using cellulose acetate, you don't have to dip it in oil to make it translucent. It's already translucent. Okay. Third important advantage here is as there is no glucose now, it's modified, it's acetylated, and because of that, yes, am I audible clearly, or am I breaking? Is my voice breaking because I'm getting this notification that my net connection is unstable? Am I clear?
Yes, sir.
Okay, good. So, so now in case of cellulose acetate, you don't have glucose here. You have acetylated form of glucose, and because of that, you can also use it for separation of polysaccharide. Now, this makes it a very big advantage for cellulose acetate. And this is where the major, you can say, to play, and that is detection and separation of glycoproteins. Now, glycoproteins are going to be essentially proteins, but they will have certain what you can say carbohydrate units attached to them, and separation of such proteins is slightly more uh, uh, difficult by using cellulose, because cellulose itself is going to contain glucose, and if you just want to detect glycoproteins, what you will have to do is that you will have to rely upon the carbohydrate moiety of the protein for detection of glycoproteins within group separately. Getting to the point, what I'm trying to say, say suppose this is a normal team, this is also normal. If you want to detect it, just this protein, and as a separate one, to rely upon the reactions which are associated with the carbohydrate units, right, attached to the proteins. And if it is cellulose on which you are performing this, then cellulose also is a carbohydrate. So it will give you a cross reaction going, and everything will be colored. So it's better that you perform it on cellulose acetate, although it's a modified carbohydrate, but it doesn't contain essentially anything which is similar to glucose now. It's chemically completely modified. So you can rely on to the carbohydrate units of proteins, whichever they may be. That they can be glucose derivatives, or they can be galactose or any other components attached to protein. So essentially, cellulose acetate electrophoresis, paper electrophoresis, has a very important role in detection of glycoproteins. And one such important glycoprotein that is detected by using cellulose acetate. Nowadays, you use HPLC for that. To perform it, it still gives you a very good result. And a protein derivative that is called as HB HbA1c. Have you heard about this? Anybody? I will write it here just for your. It's a mess over here. Okay. Just for okay, I can clear it off. Now I can write the major advantage of cellulose acetate electrophoresis procedure here. Okay. It is used for detection of what is called as HbA1c. I got an answer, I believe, at the time I was shifting. Okay, Akanksha has heard about it, uh, but this is a form of you can say cellulose acetate electrophoresis, which is used to detect. Hb stands here for hemoglobin. So it's and hemoglobin, as you all know, is present inside RBCs. So if this is an RBC, hemoglobin is inside it. Interesting thing is like when your blood glucose levels go beyond a particular point, which is essentially beyond a value of 180 mg per dl of blood. That means if the glucose level more than 180 mg per uh, deciliter, that is per 100 ml of blood, then what happens is that the extra glucose which is in RBC and which is completely metabolic, this goes getting added onto hemoglobin. Getting the point, getting modified. Am I clear? Yeah, I believe that. Okay, am I audible now? Okay, I will be sharing my screen again with you. Really very sorry about this the internet connection. Okay, good. So I hope that you can see my screen. Quickly rush. So we were talking about the glycoprotein detection by using the cellulose acetate vapor electrophoresis procedure. And so, yes. So what happens ultimately is this, that extra glucose gets inside RBC and which is unmetabolized will actually be used by the cells to modify hemoglobin. So hemoglobin will get modified into what is called as HbA1c. Okay, and there's a modified form of hemoglobin that you can measure and you can find out by performing cellulose acetate electrophoresis procedure. Okay, so you can separate it from normal hemoglobin, so you will get an extra band of glycosylated hemoglobin now. Okay, so this glycosylated hemoglobin is called as HbA1c, and this can be used as a measure to track. What will you track now? You can track that how many times, depending upon what is the concentration of the band that you get. Okay, just imagine that this is your cellulose acetate paper. Okay, just imagine that this is your cellulose acetate paper. Okay, and you are performing electrophoresis. So you have loaded your sample here. It migrates. You get a band of hemoglobin, and you get another band of glycosylated hemoglobin here. So there is one band of hemoglobin, this glycosylated hemoglobin. You can actually quantify this. What's the concentration? And on that basis, you can judge. Now, even a normal person can have some level of glycosylated hemoglobin. But if the person is diabetic and cannot control the sugar, and it's essentially kept above 180 mg per dl many times, then the band will become more darker and darker. So you can find out that what's the concentration of glycosylated hemoglobin. And now uh, inside in your blood, the lifetime of RBC is somewhere around 120 days. Comes to somewhere around 4 months roughly on an average. So when you're talking about glycosylated hemoglobin, hemoglobin can be released outside from the RBC only after 4 months, right? Roughly consider 3 months. Now, if this is so, then you can get more amount of glycosylated hemoglobin only when your sugars have been very high beyond 180 mg per dl consistently for more than 4 months. Then only then you can get a very high concentration of glycosylated hemoglobin. Say, imagine within 3 months, there was only one or two instances when your sugar levels were beyond 180 mg per dl. Then your glycosylated hemoglobin band will be quite faint. However, if it has been consistently over 180 mg per dl for more than 4 months, then you will get a very dark band. That is an indicator that your system was not able to maintain hemoglobin, maintain blood glucose levels very critically, and hence they were beyond 180 mg per dl. Actually, the permissible value is 140 mg per dl, but glycosylation happens more or less around or beyond 180 mg per dl concentration. So that tells your medical practitioner that there is a problem with your system of handling blood glucose, and that can tell the person that okay, the sugars have not been managed pretty well, and that indicates that the person is suffering from diabetes. Other way around, this is not just a diagnosis of diabetes, but if somebody already has been diagnosed with diabetes, right? But what people nowadays do is that they know when they are visiting the doctor, then for last 2 to 3 days, what they will do is that they will uh, follow the diet that has been given to them by doctors, say for last 2 or 3 days. Okay, and then they will go for blood sugar analysis, which is the fasting sugar and the post meal sugar, right? This appears to be very normal. Fasting and post meal levels appear to be very normal if you follow the instructions that were given to you by the doctor regarding your diet for last 2 3 days. Just so you can fool your doctor saying that okay, my fasting post meal is good. So why I need a lot of restrictions? I can go beyond a bit of restrictions. However, Your doctor knows on the basis of HbA1c value that whether you were practicing the same thing for more than 4 months or not. Are you getting my point? So this is a very interesting way of monitoring by the clinical practitioner that whether you were properly following the diet restrictions that were given to you because of your diabetic condition, and if you were not following it, your doctor can make it out very easily just by looking at your HbA1c value, and that can be detected by using cellulose acetate paper electrophoresis procedure. So that makes it a very interesting and very important method of detection of glycoproteins. One more interesting facet here is about, as I already told you about the detection method, when you are talking about cellulose acetate electrophoresis procedure, it has very less background staining, and that is very helpful for you to determine, to find out that whether you were that is where is the location of your glycoprotein, and otherwise the background staining will not be able to you will not be able to visualize if you use a normal cellulose paper electrophoresis procedure. So so all in all, I believe almost okay. So what I will do is that I will not begin with gel electrophoresis today. We will restrict ourselves to paper electrophoresis only. There are a few things about paper electrophoresis now that one needs to pay attention to, and that is uh, whether you are performing cellulose acetate, because it's slightly costly compared to normal paper electrophoresis. Uh, there could be there could be an important problem here. The problem is that because of very less buffer being held up onto cellulose acetate or onto cellulose compared to the amount of buffer that is held in gels, the amount of buffer or liquid that is held onto normal paper or onto cellulose acetate is very less, and hence no matter which form of paper electrophoresis you are performing, there is always a problem which is associated with excessive heat production. So excess of heat is always a problem here, and that uh, has restricted the use of paper to a great extent. And apart from that, there is a problem related to resolution, but that problem can be taken care of if you remove the hydrophilic or absorption power which is associated with paper and modifying the paper to cellulose acetate. So, so there was a need that you need another kind of a stabilizing media that can work better than paper and give you better resolution. And that is why gel electrophoresis was developed. Now, there are a few things which make paper electrophoresis still viable. That means one is cellulose acetate electrophoresis, which is still in use. Conventional paper electrophoresis is not very commonly used these days, but a modified form of conventional paper electrophoresis can be used, and that we'll talk about slightly later on after understanding that which drawbacks of gel actually made people to reflect upon paper electrophoresis back and perform paper electrophoresis for only some group of molecules. Okay, so there is only a very small group of molecules that are still being separated by using paper electrophoresis. So it's not completely phased out. So the point that you should take home along with you is that although paper electrophoresis suffers from a lot of drawbacks, some of the drawbacks can be taken care of by modifying paper itself. But still, uh, uh, it is in use. It hasn't been phased out by gel electrophoresis. Okay, gel electrophoresis is very popular, but paper electrophoresis is still in use only for certain very small group of molecules, and that we will discuss later on when we understand that what are the advantages of gel electrophoresis and what kind of disadvantage it also has, and hence you require paper electrophoresis to be used. So in case you are having any questions regarding what we have discussed today, so I'm ready to answer. Or else, what we can, what you know is you can just mark your attendance. You can give. So if you have any questions, I'm there to answer questions. Yes, any questions?